Now next we have Jahn Teller effect and electronic spectra of the complexes. So and now electronic absorption bands in spectra of coordination complexes are associated with DD transitions. Whatever electronic absorption bands or electronic spectra we see in coordination complexes, that is due to DD transitions which arise due to excitation of electrons of the metal ions from lower energy d orbitals to higher energy d orbitals. From lower energy d orbitals, the electron rise to the higher energy d orbitals. Now, due to excitation of electrons from lower energy, this is the lower energy d orbital, on absorption of energy to higher energy d orbital, electronic spectra it arises. So यहाँ पे हम एग्जाम्पल लेंगे ऑक्टाहेड्रल कॉम्प्लेक्स टाइटेनियम का, टाइटेनियम H2O whole 6 3 positive. Now in this complex the metal ion it has D1 configuration. Now in ground state the electron occupies one of the T2G orbitals. There are two orbitals, you know, I have already discussed this complex. Splitting in this complex has already been discussed. So in this complex the metal ion has D1 configuration, and in ground state the electron occupies one of T2G orbitals. The EG orbitals, they remain vacant. This complex absorbs radiations in visible region of spectrum around 5000 angstrom wavelength. Now the energy absorbed, it excites the solitary electron to one of the EG orbitals. Obviously from T to G it will go to EG on absorption of energy which is 5000 angstrom in the visible region of the spectrum. And this absorption, it gives rise to a single symmetrical absorption band in the spectrum of titanium H2O whole 6 3 positive, this complex. And but in actually what kind of spectra we observe is, we absorb this kind of spectra which is not symmetrical. It should be symmetrical but it is not symmetrical, it is unsymmetrical kind of spectra. This is the unsymmetrical spectra, an absorption band observed in spectrum of titanium complex. Now this is due to Jahn Teller effect. This we already discussed Jahn Teller effect in D1 system. The ground state in D1 system, the ground state electronic arrangement in which the solitary electron is present in dxy orbital of the complex metal ion is more stable. Now due to the presence of electron in dxy orbital, the octahedral geometry of the would get distorted to टेट्रागोनल ज्योमेट्री. ये हमने ऑलरेडी डिस्कस किया हुआ है कि कैसे dxy में जब आपका ऑर्बिटल होता है तो कैसे वो इलेक्ट्रॉन होता है, तो कैसे जो ऑक्टाहेड्रल ज्योमेट्री है वो ड्यू टू जॉन टेलर इफेक्ट वो स्प्लिट हो जाती है, टेट्रागोनल ज्योमेट्री में कन्वर्ट हो जाती है, in which the titanium OH2 bonds along Z axis are shorter than those along XY axis. Already discussed Jahn Teller effect. And the energy of dxy orbital becomes less than the energy of dzx and dyz orbitals. This is also due to the Jahn Teller effect. Therefore, the lowering of symmetry of titanium complex from octahedral to tetragonal due to Jahn Teller effect splits the excited states and makes possible two electronic transitions. There are two electronic transitions which become visible. One is dxy, from dxy1 to dx square minus y square 1, and the another is from dxy to dz square. So this kind, from dxy to dxz yz, this is one, and dx square minus y square to dz square, this is another split in the configuration. Now as the energy difference delta 2 is the energy difference between these two, and delta 1 is the energy difference between these two. As the energy difference delta 2 between dxy and dxz yz is very small, the population difference between dxy and dxz yz, levels is also very small. So therefore the ground state of titanium H2O whole 6 3 positive is written as T2G instead of DXY1, so that the two transitions are more commonly called T2G1. Yes, from T2G1 to dx square minus y square, or from T2G, because T2 the जो T2G की जो split है आपकी कॉन्फ़िगरेशंस और जो स्प्लिट लेवल्स हैं उनमें एनर्जी डिफरेंस नेग्लिजिबल है, तो उसको डी एक्स वाई जेड डी जेड एक्स लिखने की जगह वी कैन राइट T2G1 ऑल्सो, और वहां से फ्रॉम T2G1 इलेक्ट्रॉन मूव्स टू आइदर डी एक्स स्क्र माइनस वाई स्क्र और टू जेड स्क्र instead of dxy. This is what I have explained, dxy to dx square minus y square and dxy to dz square transitions respectively. Yes, this is when the electron that is present in dxy. The energy gap delta E1 is not of much difference from delta E2. The energy gap has not much difference. Now the two factors which determine geometry of the complex of the ions in this are, one is Jahn Teller effect, which favors the geometry of geometry C for titanium H2O6 3 positive, in which dxy is lowest energy orbital. Please pay attention. And the thermal energy available to the complex ions tend to equalize the population of complex ion in two distorted geometries C and E, compression and elongation. So that's all about it. Thank you.